So welcome everyone, thanks for joining. Let's talk about effortless software development today. The reason behind this talk is because I noticed that a lot of people are behind on their backlog. So people have a lot of work they need to get done and things just don't seem to get done very quickly. Some companies are actually 300 years behind on their backlog. And the reason we know this is because with one of the teams, we looked into one such backlog and extrapolated based on how long it took to accomplish those things. And we found out that it's going to take 300 years to complete all of these user stories. And we saw that it was a lot. It was ridiculous. So I tried to compile all of the things that I was doing that was helping us ship things faster, and that's what I'm going to share with you. And it's not just about the code; it's going to be about all sorts of advice regarding how to organize your work. So it's about some tasks. So there are many tasks that go into the development software lifecycle. So besides the code, there are also these tasks. You have to figure out your requirements. And after that, once you have the requirements, you put them in a document, which usually is quite long and very exhaustive. Then you have to approve that document. So once you have that, you have to go to all the different people and wait for them to read it and approve it. And then you finally get to writing the code. So you see that you already spent a lot of time on those original tasks. But then that's not over, because once you're done writing the code, or while you're writing the code, you sometimes have to wait on someone else to do something. You need information, you need code review, anything at all. You're always waiting on someone else. And then once you're finally done waiting and you finally finished writing that code, then you have merge conflicts, because it took you so long to write that code that now you have to figure out how to push all of that into master. And then you have to wait for the user tests, because they have to go through everything that you've written, and they have to approve, make sure that it satisfies all the requirements. So they're going to poke around the application and tell you whether something is wrong. And there will be. Sometimes it's not even bugs. They're going to talk to you about missing requirements. So you think, well, where are those requirements coming from? How come we did not figure them out in advance? Well, because you can't really know everything in advance, right? And then once you write all of these new requirements down, somebody you never heard of is going to just come out of the blue and is going to tell you, well, I disagree with that. It's not what we need for our department, because you have lots of users in your application, and somebody's not going to like that. And that is more true for the large enterprise. So it's a lot more than just writing the code. And then, based on those requirements, you might have to redesign everything. So you're pretty much back to square one. You have to throw away most of the code, and you're going to have to start from scratch. So at that point, there's just despair, because nothing ever gets done. So in addition to all of these, you still have, while you're in the code, you still have to figure out 20 levels of inheritance, because you're dealing with legacy codes. Maybe you have 800-line methods. Maybe you have 6 levels of nested if that nobody knows what it's doing anymore at that point. And obviously, there are not going to be any tests. So how are you going to unit test all of that stuff? And then when you're reading the code and trying to write your unit test, you're trying to figure out, well, is this variable null right now? So this is more true for PHP than other languages, because things can just be null. You don't have to assign any particular value to it, or it can have a completely different type. So you're not sure about that. And then you have, bad variable names such as array2, which means absolutely nothing. And then you have to go up, 600 lines to try and figure out what it actually contains. And it can be very complex code out there. And so yes, you are desperate because nothing ever gets done, and you just want to write code. You just want to get to the good part faster. So how are we going to do that? How are we going to trim all the fat from this gigantic process? And how can we put less effort into a better result? So, and why should you listen to me at all? Well, my name is Filina. Hopefully you found this webinar by following me on Twitter. But if not, I've been coding since '97. I've been doing PHP since 2003. I dig into old code bases so that you don't have to. I love automating tests. I give talks and workshops. I have a YouTube channel that you can follow for some programmer specific videos. And I work for Zenika Montreal. So if you're looking for a job, you can always check out what openings we have. So let's look at ways to make this huge process simpler. So this is split into 3 parts. The first part is about writing better specifications. And obviously everybody knows that. Sure, like we do need better specifications, but how do we actually achieve that? Do we just blame it on someone else for not giving us the right specifications up front? Well, think about being on the other side. Are you always able to express yourself in a way that the other person understands without any question? For example, I know that with my kids, I can give them instructions and they're not always going to do exactly as I told them, because I did not necessarily think about all the little exceptions there, and maybe they understood a completely different direction. So it works both ways, and I'm going to show you how to deal with that. So the way this works in the traditional process is you sit down with a bunch of people and you discuss requirements. And at the end of that, you're going to produce maybe that 50-page document that nobody's going to read. It's going to become quickly outdated. It's going to go rot in the company's Confluence, SharePoint, Google Drive, whatever you're using. And then based on that specification document, we're going to start the development. Great. And then we have a question about the requirements because it's not always very clear. So then you're going to go back to these people and you're going to wait for an answer. And because it might be a committee of people making the decision, you might have to wait a very long time for an answer. Those questions, I know in some companies, I had to deal with email chains that contained a dozen people in CC. And then everybody has a different opinion about how things are supposed to be done. So it takes a long time to get all of these people on board, and you have to manage all that in addition to trying to figure out how to develop any of that. And then you go for user testing. Then somebody will test it and give you a list of all the use cases that don't work or that have been missed by the requirements, despite asking questions, because of course people cannot know everything up front. And sometimes that can bring us all the way to square one. I mean, you can just have to redesign everything based on those new user requirements. And of course, while you're doing that, basically you push that into the second sprint, and then you have another question and another question, and it just continues like that. You have more testing, and you can just continue like this for a month. You can just do iterations. And companies think, well, if we have sprints, right, we put something that can fit within a sprint. But if you just keep redesigning everything, you keep adding to the existing user story, it's never really going to be done. So sprints do not solve the problem. Not that using agile methodologies is inherently bad. I mean, it's pretty good, but it's not going to solve all your problems. So you have to think about how to change the approach to requirements to make this work better for you. So the solution is multiple parts. First of all, get yourself a product owner, and you can look up the definition for more information about that. But basically, this will be the go-to person for requirements. It is a person, generally not a committee, although you can have multiple product owners, but try to always speak to one person who's going to be able to speak for all of these. So the idea is their job is to talk to all the different people. So instead of having an email chain with a dozen people, the product owner is going to take care of that. That's literally their job, is talking to all the people to understand what the system needs to do and be able to give you a more definitive answer as to what has to be done. so that you can focus on the execution side of things. They can also ensure that requirements don't necessarily contradict each other, because that happens very often, where one person tells you, well, this is what we need to do, and you go ahead and you start code that, and then somebody comes and says, well, this is not exactly what we wanted to do. We wanted to do something else. We have a different opinion about that. So at some point, you need somebody who can, have a more definitive answer. And you need to have direct and quick access to the product owner. You shouldn't have to go through someone to get to that person. You should be able to pretty much pick up the phone and say, hey, do you have 15 minutes? I need to discuss this edge case. So you have to have that direct access. And then, of course, that person ideally should not have any other roles in the organization. And it's something that I've seen too, where product owners also do a whole bunch of other things that leave very little time for being a product owner. A product owner is a full-time job. So it's very hard for that person when they have other commitments elsewhere. They can be serving multiple teams, that's fine, but as long as they have the capacity to answer all the questions. If you see that they are always unavailable, always in meetings, you can never reach them, then you have to tell them, well, you got to rethink your commitments. Maybe you're biting off more than you can chew. And that person should also not delegate questions to other people, because again, if they delegate the question, that other person might not necessarily have a definitive answer for you, and so you're back to square one. So they should be the one getting all the information, making sure that everybody agrees on what has to be done, and only then give you the answer to your question. They should not just send you off chasing, requirements. And then, of course, all of this, without any sort of test, all of this can be subject to interpretation. It can be pretty vague. So what I recommend is that you communicate those requirements using acceptance tests. Now, the way to express those requirements is often to write gherkin scenarios. This is one choice that you have, but it is one that I really like a lot, and I'll show you how it ties very well into the rest of your process. The idea is we write those specifications using natural language, and then we can automate the execution of these scenarios with BHAT or Codeception or any equivalent that works with Gherkin. And so let's look at one of those scenarios. A user can subscribe with a credit card. So think about something like GitHub, where you have a plan, so you want to be able to subscribe. So given I selected a membership option, so I, as whoever is using the system for this particular scenario. So given I selected a membership option, when I enter valid credit card details, then I should see a payment receipt. So how do you know whether a transaction has succeeded? Well, the answer to that is not, I want to see a record in a database. So that's how you would do those things in unit tests. You would say, well, then I see something in a database. The way it works with Gherkin scenarios is you have to express something that makes sense to whoever is using the system. When I shop online, I don't care what's in their database. What I need is a receipt, because if I have a receipt, let's say I purchased something and it had to be shipped to my house and it hasn't arrived for a very long time, then I can contact their support and say, hey, I have a receipt here. Not like, please look it up in your database, because they can just say it's not there, but I know I paid. So I have this receipt that proves that I made a payment, and I can show it to them, and I can say, hey, well, please actually send this item to me that I ordered. So a receipt is what really counts for the user of the system, and that's how you should express it. Don't think in technical terms. Whether it's in the database, whether it's even on paper, it doesn't really matter how the system stores it. What matters is what I, as the user, can actually see on my end. So this this scenario here that you see is what I like to call a happy path. So this is basically when everything works fine, this is what happens. But you can have other scenarios where, for example, you have an invalid credit card, and it can also be invalid in various ways. It can be invalid in the sense that it has expired, which is different from it's invalid because it's not a number that exists. Or it can be that it's invalid because you are attempting to ship something to a different country than where you're purchasing from. That can be a sort of fraud alert. So you can have a variety of ways in which a credit card can be invalid. And you can have all the different scenarios to account for that. But at least start with this one. And I actually like to put these scenarios, these happy paths, inside of my user stories. So when we do the grooming ceremony where we try to sort of understand the story, a user story, try to size it up, and figure out what other information we need, we found with several teams, we actually found that having the happy path is really not only reassuring to everyone, but also allows everyone to have a mutual understanding of what needs to be accomplished. If you show this, so if you discuss it with the product owner, they're going to say, well, let's start with that. This is great. This is how I see this scenario. And then other people on the team, the developer might say, yeah, sure, I can see myself implementing this. I have a fairly good idea of how we're going to do that. So they can give a size to that user story, and they're confident that they have enough information to get started. Somebody else, such as the tester, can say, yeah, sure, because now we have this basic scenario, I know how we're going to test that. And in one of the teams where I worked, the testing, not knowing how we're going to validate that the scenario is true was the biggest reason why they were always estimating things much larger than they were supposed to be. Once we had that, the size has shrunk, and we were all sort of aligned in our perception of how big the story was. So this really gives us the information we need to move forward. So we actually made a happy path one of the conditions for what it takes for a story to be ready to sprint. So we cannot start a sprint until we have this information in the user story, which means that we have discussed it thoroughly. But the thing is, we don't always have to focus on user interactions, because sometimes, well, first of all, you can have a backend application that has to interact with a front-end application, so the use cases will be slightly more technical, but from the perspective, again, not of a developer, but from the perspective of whoever is using that system, which is, let's say if you're running an API, the front end, the front end application is using the backend application, so they need certain types of scenarios. Now, you can also have very specific scenarios. So here is an example where we are applying a single business rule. So let's say we have a complex discount system, and all of these scenarios that you're seeing here are actual scenarios that I wrote. Well, I mean, not word for word, but slightly simplified. But the idea is these are scenarios that you would write in a real project, so it's not just an example. So discounts are matched based on the current date, because you can have discounts based on various criteria. You can have a discount like, I don't know, Black Friday. You're going to have a current, because of the dates, everything is half priced, let's say. And maybe you have something that is very specific to a particular product, and maybe the product combined with the date is a discount, or maybe you get a discount because you have some membership card. Whatever the criteria is, we had, I think, 5 different types of discounts. We even had to go as far as check what is the issuing bank for the credit card based on the credit card number. The first 6 digits is the BIN number. And so we were able to say, well, this was issued by that institution, therefore they get a discount because there was a deal with that institution. So anyone who would pay with such a credit card will automatically get a discount. So the scenario is given a 5% discount. with the name 5, which I like to use names that are easy to interpret and then easy to understand later on as you read the scenario. So 5% discount named 5, active on basically through the month of January 2019, and another one of a 10% discount active in February. Okay, so we have basically 2 discounts here because that will allow us to select the correct one. So that is the business rule that we want to apply. And the current date is January 15th. So we already know that it's supposed to be the 5% discount that is picked. And yes, so when I check for discounts, the 5 discount should be found. So you can express it any way you like, but in this case, we want to make sure that the business rules are well understood. So we're not really focusing on the user interaction and what the user sees. We just know that this is the discount that should be selected. The way it's presented to the user is a different story. And this is something that is particularly useful in certain environments where these rules can be audited, like in a bank. So if you are working for a bank, you very likely have already seen tests like that, where you have sometimes hundreds of business rules. Let's say you're parsing a large CSV file and you're applying all of these rules. These have to be audited because of all the regulations. You cannot just apply discounts, for example, any way you like. So to know that these things are then automated, give the auditors enough confidence, and you don't have to walk them through your code, basically. So it removes the burden from you, but also allows for the product owner to go through all of these rules and make sure that they're actually correct. So if anytime there's a bug, they can just go through the appropriate scenarios and see where we made a mistake. So maybe we made a mistake in the scenario itself. So those requirements are basically just a collection of use cases that you need to account for. And if you use natural language, no programming talk, they can actually be read by non-technical people. So that's the whole point. It is then up to you, the developers, to transform it into something executable. And I'll show you an example later. Right, so let's see. Once we incorporate this new approach, the workflow changes a little bit. So at the end of our meeting where we discuss requirements, instead of emerging with a 50-page document, we emerge with a collection of use cases. And those use cases don't have to be expressed in Gherkin because maybe the business people are not very comfortable with something that looks like programming stuff. So I can just transform it into little boxes with arrows because everybody loves those, everybody can understand them. And even with some of the most difficult business people, like those who wanted to keep everything non-technical, they ended up, after a few iterations where we did that, they ended up actually preparing those sort of diagrams for me. And all I had to do is just copy paste those into Gherkin, and that's it. I even thought about automating the whole process, but it was good enough for me. So every company can be convinced, even large enterprises who are not used to something like that. Right. So after those use cases, you can start developments. But then if you have a question, instead of getting like some random answer in an email, you can actually try and discuss and come up with a new scenario, either change an existing scenario or create a new scenario for the various edge cases. And so you can significantly reduce the number of problems that are found during user testing. And the thing is also, you can postpone some decisions. So here's a story that happened at a company once, fairly recently, about a year and a half ago. So what happened is they had a whole bunch of requirements, and after 30 minutes we already knew all the requirements. And then they spent 1 hour disagreeing about an edge case. And I said, you know what? I don't think we're going to be able to resolve it right now. How about you gather all the necessary information to find out how we need to deal with that edge case? We are going to start developments, even though we don't have all the information, because we can just design it in a way where we can very easily incorporate, one way or the other, depending how you want to deal with this scenario. So we're gonna we're going to have a design that sort of accounts for that new scenario, even though we don't know the exact outcome that we wanted to have. So it allows you to postpone decisions and start development much earlier than you would normally, because I don't even think they ended up caring about that particular scenario later on. So we possibly saved ourselves months of back and forth, and we would have needed to groom a different story because of that. So we would have never implemented that feature. So it really allows you to save a lot of time by pushing those decisions later. And once you have the minimum viable product, you might not even care about that scenario at all. Because once they see what it does, they're pretty much satisfied with that. Right, so the second part, so we spoke about design, and I like to do it in an iterative way. So if we do all the design up front, what's going to happen is it will be very hard later to adjust if there is a mistake. So be careful. I'm not saying that you should not spend time doing design. You should just not do all of it before you write a single line of code. So you have to do a little bit of design, do a little bit of code, and just iterate like that. And I'll show you how. So normally how it works is you would spend weeks designing, and then you will have to seek approval by all the right technical people. That can sometimes take weeks. And then you start developments, but then you find cracks in the design. You find all the mistakes you made because you could not have foreseen everything up front. And the reaction of some people is once they see those mistakes, they think, well, we have to spend more time designing properly so that we avoid the mistake. Well, no, because you cannot know everything in advance, especially when you're dealing with code that you didn't write. Maybe that's poorly designed, maybe it doesn't have any tests. So what you should always consider is this quote by a Polish-American scholar: the map is not the territory. So what happens if a plan has a mistake? It doesn't account for a detail. Do we have to start the plan over? I mean, we're already there. We can't necessarily go back. So what you need to do is you have to be prepared to adjust. And the way you do that is by starting with something very simple. So don't go in coding right away. Start with just a simple sequence or activity diagram. That takes like 10 minutes. So the sequence diagram is something I use if I have just a single use case. So I usually use that for the happy path, regardless of how many use cases I have. And then once you have all the different conditions, you can have an activity diagram. So it represents basically the same thing, just in a different way. A sequence diagram is just a single use case. And so then you're going to write some minimal code to validate the design. And I'm going to show you both of these things, how they happen in practice. So the idea is to allow information to freely flow both ways between the code and the design. And it prevents us from spending excessive time on details that may eventually prove wrong, especially with code that you haven't written. You can have like this big design, and then you go into the code and you realize that it's not at all what you expected based on all the information you gathered. Because once you have your hands in it, that's when most of the information comes to surface. So the way I like to design my sequence diagrams is to split by application boundaries. You can have your own approach if you like. What I do also is, if I have like say if I had a third-party payment gateway, I would also represent it here. For this scenario, I'm going to keep it simple because we're just going to go with the user, the UI, and the API. So we have a front-end and back-end application basically. So what we do is we go back to the use case that we wrote in Words, where a user would select a membership. So the user only interacts with the UI, but then the UI is going to create or ask the API to create an order based on the product that was selected. So the product being the membership. And then the API is going to figure out how to store it. We don't need to go into any of the technical details. What it's going to do is going to send you back an order, and the order basically that includes any tax calculation, whatever you need, any discounts maybe that you have, and then it's going to give the user a payment screen. And then we're going to enter some payment details, and those payment details will allow the UI to request to finalize the order using the credit card that was input. And then the API is going to process it any way they like. We can decide on that later. And it's going to send a receipt with, most importantly, the confirmation number. So that's the reference. And then we're going to present the receipt to the user. Exactly which fields we send are not relevant. We just put, the strict minimum in this diagram. We didn't have to do that, but it just helps us think. Since we already have that information, we already know it's going to be like that, might as well just continue with that. And so once we have that, we can write the minimal code in order to make sure that this makes sense. And if it doesn't, then we can go ahead and revise this diagram. So the third part of this, once we have some sort of a design, we want to be able to work in parallel as much as possible. So a lot of the times, there's this expression, too many cooks in the kitchen. Basically, people are always stepping on each other's toes. And most people tell me that you cannot have two developers working on the same user story unless it's really big and there's actually like sub-stories. I don't believe in that because I have proven this to be otherwise. I have proven that it is possible to have a lot of people actually coding at the same time on the same story and not step on each other's toes. Because people say, well, we're going to be working the same classes, we're going to duplicate efforts, we're going to have plenty of merge conflicts. It doesn't have to be. And the way we approach that, and that I have done on several teams with a lot of success, pretty much works every time. So you should really try that. So the solution is you start with more programming to validate the design. So the way you do that is everybody sits together and one developer is going to share the screen and you're going to start writing. And it works very well remotely, actually, because you just need to join the same meeting online and see what's happening on the screen and then comment on that. So once you do that part, then you can split the work. You're going to have to do some implementation. You're going to write some tests, and I'm going to show you exactly how to do those two steps. So once you sit down together, you start by looking at the diagram that you created. This diagram is going to guide you for the rest. Of course, you can amend it if you find mistakes in it. So that's the point. Now we're going to have to write some basic code in order to make sure that this diagram actually makes sense. Since we're working on only the API, we're not going to worry about the interaction between the user and the UI. We're just going to worry about the part between the UI and the API. So the first thing that we're doing here is we are creating an order using a product code, and then we'll return the order. So the way I see it, there is a request and response. So we have two of those. So we're going to have to write two controllers or handlers. So we can just go ahead and write one of these handlers. So in MVC, that's what it might look like. Some frameworks would have multiple handlers per class. So it's going to be like a something controller, and then you have something action. This is an example where it's just one class. I actually enjoy writing one class because then I don't have a whole bunch of dependencies that might not even be used in that class. Imagine if you combine, printing and getting stuff from the database in the same controller, then you might have all the print-related stuff, generating PDFs and such that make no sense for all the other actions. So I kind of like to isolate things. So what we do here is we handle the request. So we receive a request and then we're going to send back a response. So this is pretty straightforward. And then we're going to grab the product code from the request. I like to create what we call value objects, and you can actually look it up. I have a video on that. I'll give you some more information after this talk. So the idea is you create this instance that in the future we'll never have to check whether it's whether the string is null or false or empty. We know that it will satisfy all the requirements to be an actual product code. And so once we have this product code from the string, we can then get it from the product's storage wherever they're stored. If they're stored in a database, CSV file, maybe a microservice, I don't know, really depends on your architecture. That is a technical decision you don't even have to make at this point, because as you dig deeper, you're going to uncover more information. You don't have to have all the information up front. All you know is for this request to work, you need a product code, and then with the product, you can then create an order, and now you have an order object that you can return. And you return it by let's just call it serializing to array. What exactly it will contain, again, it can change. You can put some minimal information in there, and then once the UI becomes a bit more advanced, they might come to you and say, well, we also need this information. Let's say you gave us just the monetary amount of the discount, but now we also need to know the currency for that. Okay, that's fine. You can always incorporate that later. See, we have a design that can adjust. If we uncover that the products are stored in a CSV as opposed to a database, or like in a microservice as opposed to a database that we can access, then we can just implement it this way. We don't have to make that decision at this point. So this is basically our design. There are a few things missing though. So once you spell out the entire handler, because the handler is very simple, it's the glue that holds everything together, and it makes sure that you didn't forget anything. So if you wanted to create an order without the product code, you would have seen that right away in this handler, and it will guide us for the rest of the work. So note these two dependencies, the products and orders. We are going to use dependency injection, which means that we will pass them into this class from the constructor, so that the second you instantiate this handler, you already have access to that, so you're guaranteed that it will not be null at any point. And we are going to write them as interfaces. So product storage is actually an interface, it's not an implementation, because by doing that, we can start unit testing the handler without having implemented any of those storages. And so as the entire team, we take the time to spell out those interfaces. So here we have the product storage with the get by code. And then we have the order storage with create. So both of these methods we have used in the handler. So if you haven't used them in the handler, don't put them there. Don't basically write that code up front. And so nothing else, just these things. And then you will see that we have a couple of additional classes to create. We don't actually have to go too much in depth. I'll show you how it looks like when it's complete. Yeah, the thing is, you don't necessarily need to write the part with assert at this point. I just want to show you the whole point of having a value object so you can see what it's like. So the idea here is that it's immutable, meaning that you cannot extend it because it's final. Because if you were able to extend it, you'll be able to override the constructor and therefore change the rules, and that means that it's no longer immutable. So the idea basically is you receive some value or a couple of values, not too many. This is not an entity. So receive a couple of values, then you validate them. So basically this thing will explode if your code is either blank or exceeds the maximum length. And then you store it, and the code is private. Then you have a public method, get code, that allows you to extract it. So there's only one, so you can only set things, you can only instantiate with the code, you cannot change the code after the fact, which is what makes it immutable. And so you just have to write, a constructor with the code, get code, and that's it. So this is something you can do, again, still fairly quickly while you do your mob programming. You can later refine the object, add tests, figure out the remaining information that you need. Dig up all those documents that explain what a product code should look like. You might get some surprises. Is it alphanumerical? Can it have dashes? Things like that. So this mob programming, it does sound like a lot of work to do as a whole team, but really the handler only took 13 lines of code. All the interfaces combined, 8 lines of code, including the curly braces, right? The value objects, 46 lines total. So and I mean all the value objects combined once you spell them out. So that's 67 lines of code. That's really not a lot. It's something that you can very easily do in under an hour. And then you grab it and you make a pull request to master, and that's going to be your design. So for now, because nothing is wired into the application, you don't really risk breaking anything. It's just you have code that's not tied into something, anything yet. If you're extending existing behavior, you can use feature flags. So look up that term as well if you're not familiar. Feature flags can really help you deal with code where it's not just about writing new classes. And so this exercise that you do in under an hour gives everyone a shared vision of what needs to be done. And then you can split the work. You can have one developer unit testing the handler. You don't actually need to bootstrap the entire framework for that. You don't even care at this point what the framework is. You can make that decision later. So you can postpone a whole bunch of decisions using this approach. So you can unit test the handler because you can mock the two interfaces that get injected. You don't mock value objects though. You have to use them directly. So after that, you have to implement the interfaces and write the test for them. So you take the product storage, you make an implementation for that. Either it communicates with a microservice or reads a file or connects to the database. You decide how you want to implement that, and then you write tests for that. Then, so all of them individually. So we have one handler for now. We have two interfaces and their tests. Then we have to implement the validation of the value object and their tests. So basically, you just throw a whole bunch of invalid values at it, and it has to explode and only work with the valid values. So implementing the value object, that is 3 different value objects. So that can occupy a few more people. Everybody should, be in charge of finding the information for their value object. Is it 15 characters? Is it more? Can it sometimes be 9, sometimes 11, which is actually possible. It's possible to have multiple types of product codes. I've had that in the past where an account number actually had two different sources, and therefore could be either, I think, 11 or 15 characters. It was really strange. It was an interesting discovery. And then you can implement the different steps for the acceptance tests. So with this, you can have, at this point, 7 developers working on this without stepping on each other's toes. Hopefully you don't have teams that are that large, but you can see how it's very easy to not step on each other's toes, because the only thing that binds you together is that handler and those interfaces. And if you do need to make some changes to the interfaces, to the design, you have to sit together again. Let's say you need a new argument because the order, depends on the country, because some countries maybe have different taxes, things like that. So how about we pass that also to the order storage? So you sit down, you make that change, you send a patch to master, and then you merge that patch, and then everybody rebases their current working branch, and you can just continue as though nothing happened. People might need to adjust any unit tests that they have, but that's not a big deal. So you make the necessary change and you move forward. So it's very easy to revise the design, as you can see. And then for the acceptance tests, there are multiple approaches. It depends really which parts of the application you control. If you have one application that encompasses both the backend and front end, you're going to have to write tests that sort of interact with the front end. And if you just are in control of the backend, then you're going to make requests to that. You'll basically send HTTP requests to the API. And so the way I do this is we take the scenarios that we wrote previously, and then I like to add the work in progress tag at the top. And so the pipeline does not get broken. So the pipeline excludes anything that is work in progress, which means you can still commit it to the repository, but you don't have to worry about it breaking the CI. And then in those steps, you essentially call the various endpoints. So these are the 2 controls that we're going to have to write. And then you write the step definitions as best you can, given an incomplete implementation. and then you commit that. And once again, it's not breaking anything because it's not wired to execute. And then as things get written, as these endpoints become available, you can temporarily remove the work in progress tag, run it, see if it passes. And once everything passes, once all the steps are green, you just remove the work in progress and you make a commit, and you're done for that particular endpoint, for that particular test. So once all of your scenarios have been implemented and all of them pass, basically you're done. If all of your use cases have been satisfied and you have an automated test to prove it, it means that you can just go ahead and cache in those story points. And if there's something that wasn't accounted for, you can just push it to the next sprint, sure, but you still have completed the story. Then you're just going to have to deal with all of those edge cases independently. You don't necessarily have to, unless there's a big mistake. But usually this, back and forth between the design and the implementation, and also going back to the PO whenever you're not sure about something. This allows you to pretty much ship things without any surprises. And most of the things I shipped were without surprises. So just to recap very quickly, the code is living documentation. You don't have to write a 50-page document if you have this neat list of use cases that you can show to a non-technical person, get them to read through it and say whether that is what they meant. Don't try to figure out everything up front because you have a lot of unknowns. So you can, by definition, not know them in advance. So you are going to make mistakes, of course, but they are normal. Make them part of your process. Don't be afraid of mistakes. Have a process that sees mistakes as something normal. So basically you fail fast and then you go back to the drawing board. And work together more often. So pair programming, mob programming, discuss with your PO. You have to, it's not about the code, it's not about the documentation, it's a lot about make sure that everybody understands each other, what needs to be done. And then after that, the coding part is actually becomes the easy part, and you can get to it faster, which is nice. Further topics I would like you to explore, they're all topics that I actually covered briefly in this talk. Like domain-driven design. So when I talked about, all those interfaces and value objects, this is part of domain-driven design. Test-driven development, obviously writing your unit tests is very important. Behavior-driven development, that's when I discussed gherkin and how the gherkin is guiding you. So those use cases that we wrote is actually guiding you in your implementation. I briefly mentioned some solid principles, so dependency injections, things like that. I talked about clean code because of the mob programming and all that. These are part of the extreme programming teachings. And then Scrum, so you may have not have noticed it, but we talk about iterations, so grooming and such. So those ceremonies are part of Scrum. And so all of these combined have allowed me to write software effortlessly. And that is it. I will put up the slides and there will be a recorded video of this. So we'll put them on Twitter shortly after the talk. And just before you go, I'm gonna answer a few questions for you. So I'll open the room. You have a questions tab in your GoToWebinar control panel. So you can actually post questions and I will read them out loud and I will answer them. And then I also want to mention that my colleague Khaled Souf is going to give a talk, another webinar about a month from now on June 18th at 9 a.m. same time. He's going to talk about applied domain-driven design on legacy code. So you heard a little bit about domain-driven design. So he'll introduce a few techniques and heuristics based on his experience dealing with legacy code and how to apply those domain-driven design concepts to it. And that is it. I'm going to start the screen sharing and I can answer your questions. All right, so unless I have any questions, I will close this, this webinar, and thanks for joining me. All right, have a good day.